Hello everyone! In this video I will show how to build and calibrate a voltage control LFO, and I will also make a couple of demos to show you how to use it. If you buy the full kit from my Tinder shop, the box contains all the components that you will need to complete the build. This includes a double molded black and white knob, all through-hole components like connector, pots and capacitors, and finally a black and white PCB panel, and the main PCB with all SMT components already in place. Let's start the build by opening the main PCB bag. Please note that the LEDs are in that bag too. The PCB has two sides, component sides with all the surface mounted components, and the top side where all the components that are facing the front panel go. Mount the 10-pin power connector on the component side of the board. Pin 1 should be facing the white stripe on the PCB. Make sure that the connector is properly seated on the PCB. There are several ways of doing this. I prefer to solder one pin and reflow the solder joint while pressing the connector to the PCB. After that I solder the rest of the pins. Next is the polarized electrolytic capacitors. They should be mounted on the component side as well. The negative lead has a white marking on the side, and it should align with the large white marking on the PCB. The last component on this side of the PCB is the blue multi-turn trimmer. If you want the solder joints to look nicer after you have trimmed the leads, you can reflow them with your soldering pen. Alright, that's one side finished. Next we will start populating the top side with all the interface hardware and the indicator LEDs. For the next step we will need the PCB panel in order to align the components and keep everything in place. Carefully insert all the components on the top side of the PCB. Start with the pots. Then continue with the toggle switch. Insert the LEDs. The flat side of the LED should face the white marking on the PCB. The yellow LED should be in the lower position, and the green LED should go in the upper position. Insert the jacks next. Carefully put the PCB panel on and make sure that the components are properly seated on the PCB. Screw all the nuts in place and hand tighten them. This can be a little fiddly, but it's really important that everything is properly seated and aligned before you proceed. Check that trimmers, pots and switches works and feels as expected. Next you insert the LEDs into the back of the panel and make sure that they are seated as well. Now, solder everything and be careful that nothing has moved and is still in the correct position. One way of doing this is to first solder one leg of each component and then check alignment and reflow the solder joint if a component needs to be adjusted. After that you can solder the rest of the component legs. Now you can trim the LED legs. Last thing to do is to attach the rubberized frequency adjustment knob. And with that, the build phase is completed. Before starting to use the module, there are a couple of test and calibration steps that you need to complete. The first one to make is to check for shorts on the power leads. This is done by using a multimeter in beep mode. After that you can power up the module by attaching a power cable. The expected current draw should be around 15 mA on both rails. Check that the LEDs are flashing in an alternating pattern and that you can adjust the frequency with the frequency knob. The high-low switch selects the frequency range. Next step to check is that all outputs are working. The shape of the sinus output needs to be adjusted with a multi-turn trimmer. Adjust it until you get a nice round shape. This is too much, so let's dial it back a bit. This is much better. With this, the build of the LFO module is completed. I would like to finish this video by showing a couple of applications for the LFO. The LFO is excellent to use as a clock source for your sequencer. Connect the square output to the clock input and make sure that the switch is in the high position. In the next setup, I will use one LFO to modulate the CV input of a second one. Connect the sine output of the first LFO to the CV of the second one and adjust the level of the slow modulation using the CV adjust trimmer. And in the final setup, I will use the reset input to keep the LFO in sync with the sequencer pattern. Thank you for watching. See you in the next episode.